As I mentioned earlier, another type of member is a service account. A service account is an account that belongs to your application instead of to an individual end user. This provides an identity for carrying out server-to-server interactions in a project without supplying user credentials. For example, if you write an application that interacts with Google Cloud Storage, it must first authenticate to either the Google Cloud Storage XML API or JSON API. You can enable service accounts and grant read-write access to the account on the instance where you plan to run your application. Then, program the application to obtain credentials from the service account. Your application authenticates seamlessly to the API without embedding any secret keys or credentials in your instance, image, or application code. Service accounts are identified by an email address, like the example shown here. There are 3 types of service accounts: user-created or custom, built-in, and Google API's service accounts. By default, all projects come with the built-in Compute Engine default service account. Apart from the default service account, all projects come with the Google Cloud Platform API's service account, identifiable by the email project-number@cloudservices.gserviceaccount.com. This is a service account designed specifically to run internal Google processes on your behalf, and it is automatically granted the editor role on your project. Alternatively, you can also start an instance with a custom service account. Custom service accounts provide more flexibility than the default service account, but they require more management from you. You can create as many custom service accounts as you need, assign any arbitrary access scopes or Cloud IAM roles to them, and assign the service accounts to any virtual machine instance. Let's talk more about the default Compute Engine service account. As I mentioned, this account is automatically created per project. This account is identifiable by the email project-number-compute@developer.gserviceaccount.com, and it is automatically granted the editor role on the project. When you start a new instance using gCloud, the default service account is enabled on that instance. You can override this behavior by specifying another service account or by disabling service accounts for the instance. Now, authorization is the process of determining what permissions an authenticated identity has on a set of specified resources. Scopes are used to determine whether an authenticated identity is authorized. In the example shown here, applications A and B contain authenticated identities, or service accounts. Let's assume that both applications want to use a cloud storage bucket. They each request access from the Google authorization server, and in return, they receive an access token. Application A receives an access token with read-only scope, so it can only read from the cloud storage bucket. Application B, in contrast, receives an access token with read-write scope, so it can read and modify data in the cloud storage bucket. Scopes can be customized when you create an instance using the default service account, as shown in this screenshot. These scopes can be changed after an instance is created by stopping it. Access scopes are actually the legacy method of specifying permissions for your VM. Before the existence of IAM roles, access scopes were the only mechanism for granting permissions to service accounts. For user-created service accounts, use Cloud IAM roles instead to specify permissions. Now, roles for service accounts can also be assigned to groups or users. Let's look at the example shown on this slide. First, you create a service account that has the instance admin role, which has permissions to create, modify, and delete virtual machine instances and disks. Then you treat this service account as the resource and decide who can use it by providing users or a group with the service account user role. This allows those users to act as that service account to create, modify, and delete virtual machine instances and disks. Users who are service account users for a service account can access all the resources that the service account has access to. Therefore, be cautious when granting the service account user role to a user or group. Here is another example. The VMs running Component 1 are granted editor access to Project B using Service Account 1. VMs running Component 2 are granted Object Viewer access to Bucket 1 using an isolated Service Account 2. This way, you can scope permissions for VMs without recreating VMs. Essentially, Cloud IAM lets you slice a project into different microservices, each with access to different resources, by creating service accounts to represent each one. You assign the service accounts to the VMs when they are created, and you don't have to ensure the credentials are being managed correctly because GCP manages security for you. Now, you might ask, how are the service accounts authenticated? Although users require a username and password to authenticate, service accounts use keys. There are two types of service account keys: GCP managed keys and user managed keys. GCP managed keys are used by GCP services such as App Engine and Compute Engine. These keys cannot be downloaded and are automatically rotated and used for a maximum of 2 weeks. User managed keys are created, downloadable, and managed by users. When you create a new key pair, you download the private key, which is not retained by Google. With user managed keys, you are responsible for security of the private key and other management operations such as key rotation, which is illustrated on this slide.